Hello, Carlos Martinez here, student at California Intercontinental University. The following presentation is on the topic of correlations using PSPP. This is an assignment for Unit 4, and this is a Unit 4 presentation for Course 605, which is Business Research Methodology and Quantitative Statistics. Our professor is Dr. Nigel Basta. I've got 2 pages for introduction. A correlation analysis. This data set was generated using SurveyMonkey, and respondents in the Midwest United States were asked questions regarding the categorical variables outlined in our assignment, but 6 of them were selected for our testing. PSPP is what was used, and PSPP is a free open source computer application software that is used for statistical analysis of sample data. It was relatively user-friendly, and I can see that it's used for a lot more applications. I'll be using the Pearson's R method of testing. We need 2 things for testing correlation significance. The 2 things are alpha and degrees of freedom. I'm using the traditional alpha indicated 0.05 and the degrees of free indicated by the letter N, and the degrees of freedom is N minus 2. Introduction, page 2. Just a brief explanation for scatter plot and sample correlation coefficient R. Scatter plot is used to show the relationship between 2 variables. According to our text, it tells the researcher whether the hypothesis is substantiated or not substantiated, and it's used to measure the strength of the association between the 2 variables. The sample correlation coefficient R is an estimate of P. It's used to measure the strength of the linear relationship in the samples. For example, -1 is an indication that we have a strong linear negative relationship. The closer to 1, we have a strong linear relationship that's positive, and the closer to 0, the weaker the linear relationship. The sample correlation coefficient R is what we will be using to determine our inferences and our results. Our agenda. Well, in this presentation, we'll review the categories listed that were in the introduction. I took them out because I've only selected 5 or 6 of them. For each test, I'll state the hypothesis and rejection rule. The null hypothesis means that there's no correlation between the 2 variables and R equals 0. The alternative hypothesis is that there is a correlation between the 2 variables. R does not equal 0. The rejection rule is that the null will be rejected when P is less than alpha, where alpha is 0.05. The null will fail to be rejected. In some cases, it's noted as being accepted when P is greater than alpha. I'll post the main takeaways from the presentation at the end and invite questions. Test number 1, correlation test 1. Correlation test 1 is between income versus savings. The null hypothesis can be stated: there's no correlation between the participants' income and their savings. The alternative: there is a correlation between the participants' income and their savings. The correlation coefficient and its p-value was calculated by PSPP. Assuming alpha 0.05, there is a significant correlation that has been revealed. R is 0.91 and P is 0. This means that the null hypothesis is rejected, and the inference here is that there is a correlation between the participants' income and their savings. Test results number 2, income and stocks. Well, the null hypothesis, there's no correlation between the participants' income and stocks. The alternative is that there is a correlation between income and stocks. The findings, the correlation coefficient and its p-value calculated by PSPP, assuming the standard A alpha of 0.05. We have a significant correlation as revealed. R equals 0.19 and P equals 0.018. The null hypothesis is rejected, but there's a weak correlation between the participants' income and their stocks based on our findings. Savings versus stocks, correlation test number 3. Well, as stated, there's no correlation between the participants' savings and their stocks, and the alternative, there is a correlation between the participants' savings and their stocks. A significant correlation was revealed based on our testing. R equals 0.28 and P equals 0.000, as indicated by the graph at the top left. In this case, the null hypothesis is rejected, and there is a weak correlation between the participants' savings and their stock valuations. As you can see from the graph at the top, as well as the scatter plot for savings versus stocks. Number 4, the no correlation between participants' savings and wallet, and the alternative, there is a correlation. Here our results were significant as well. R equals 0.91, P equals 0. The null hypothesis is rejected, and there is a correlation between the participants' savings and wallets. Here there's a relatively strong correlation between the two, as indicated on the graph at the top left and the scatter plot savings versus wallet. Test number 5, stocks versus wallet. The no correlation between the stocks versus wallet, and the alternative, there is a correlation between the stock positions and the wallet. Our findings, a significant correlation was revealed based on the chart at the upper left. R equals 0.19 and P is 0.017. Again, the null hypothesis is rejected, but there's a weak correlation between the participant stock positions and their wallets. Weak, but still rejected. Our final test, income versus wallet. Again, there's no high correlation between the participants' income and wallets, and alternative, there is a correlation between participants' income and wallet. Our findings, a significant correlation has been revealed. R is 1 and P 0, as indicated by the graph in the upper left. I failed to mention earlier, but the N, our degrees of freedom, on the graph in the upper left on each one of the slides, and this one in particular is 150 minus 2 would be 148. The null hypothesis is rejected, and there is a correlation between the participants' incomes and their wallets. Well, let's take a look at takeaways. The first takeaway is this: the scatter plot diagrams serve to visually confirm your analysis or our analysis. I found it interesting, the various displays of the scatter plot designs and the effort in terms of syncing that with the graph that produced the actual analysis. PSPP is an effective tool to perform a correlation test, in my opinion, very user-friendly. PSPP allows a user to explore a data set from different perspectives. I haven't explored all of those perspectives yet, but I have a feeling they're coming up. Correlation is between -1 and +1 with an independent scale of variables to be examined. Well, that does it. Here are the references. some references from the textbook as well as from the software that was used. If there are any questions, please contact me. Thank you very much for your time in viewing this presentation.